Hello and welcome to Unprofessional Engineering. My name is James.
You got Luke.
Luke?
What's
It's been a long time since we've done this.
well, let's just roll, brother. We got to keep this. That's a good outtake. So, James, what are we talking about today?
Today, we are talking about space telescopes.
So here's the thing that I got to say about the space telescopes. I don't know how we didn't do this one before.
You know, we did telescopes, and we talked about the ones on like the Hawaiian Islands and the one where Aquaman is like, no, don't build it. Or maybe he does want to build it. I don't remember. We talked about those, but we didn't talk about space ones. So you're right. It only took us 300 plus episodes to get to this topic.
That's good, I think.
We found this one so interesting that we decided to do satellites twice before we did this one.
So my research is kind of like telescopes twice with a little bit of space stuff at the end.
Okay, fair enough.
Alrighty.
My first topic that I have bolded here is why space telescopes? Do you want me to talk about why?
Well,
you want to talk about why?
No, I think you can start, but let me take
thanks,
a
dude.
wild guess. Let me take a wag, as they call it.
What does that mean? Wild guess.
There's another word in the middle. I don't know what it means.
Me neither. Okay.
So my theory is it probably started originally like, oh, I want to see what Earth looks like from space. So let's send something up and look back. I think in my crack research, that wasn't the case. My guess is they couldn't see through the troposphere or whatever our atmosphere is called. You
what
like
a
that
word. It might not be the right one,
I
but
think it's
man, was
totally
that
wrong
good.
word. So my guess is there was like atmospheric distortion because of our atmosphere with our land-based telescopes, and they were like, "Hey, let's just take one of these telescopes, throw it into space, and there's no atmosphere out there to like interact or interfere with, you know, the images. So we should get these amazing images and be able to see really far."
Do you think Randy Johnson, the big unit, could have thrown a telescope into space?
Did you ever see that video where was
When
that
he
him
blew
that
up
hit
a
the
bird?
bird?
Yeah.
Oh, we are
It's
so
sad.
off track right here.
Yeah.
Go ahead, James.
Okay. Data. The best data comes from space telescopes. They need to be in space for this. And because, just like you said, Luke, the Earth's atmosphere is always getting in the way, causing problems. I think we should just get rid of it. But, you know, I guess it does other good things. The air causes light to bounce around, which makes images blurry. That's not good. It also acts kind of like a blanket, like only letting through certain types of light when it's shining through or when it's going out, and it blocks others. And so this means that we don't see all of the light from distant objects. So space telescopes also get away from light pollution. So the man-made light from our houses and our skyscrapers and whatever it might be that we're lighting up here on Earth. And so this makes faint objects way off in space a lot harder to see from the ground. Fun fact for you, Luke, the first operational telescopes in space were the American Orbiting Astronomical Observatory, the OAO2, which launched in 1968, and then the Soviet Orion 1 ultraviolet telescope, which was aboard a space station in 1971. Way cooler name. Orion's way better than Orbiting Astronomical Observatory.
So I'm envisioning that like one of them was just they were in space and they had like one of those telescopes like a kid has, and they were just like looking out the window like this.
It was like duct tape to the side of a spaceship or something.
We have a telescope in space.
I love it.
So interesting fun fact.
Oh, I'm loving
You talk
this.
about light pollution.
I am.
It's not really a fact. It's more like you should go try it if you've never done it. So I would suggest going to some place like St. Mary's, Pennsylvania.
Oh, lovely town.
And what you do is you go out in the middle of a cornfield, because that's all there is in St. Mary's.
That's a dirty
is my
lie.
guess.
There's forests as well.
But the whole light pollution is like a legit thing. So I have a cabin up in Cook's Forest area here in Pennsylvania. And when you go out at night on a clear night and you're like in the mountains or in the cornfields of St. Mary's, Pennsylvania, I mean, it is literally like it's a drastic, like you almost don't believe that it's the same sky, because like I think it's dark at night at my house and I'm like, oh, it's pretty dark, I'll go outside and I'll see some. But like when you go to some place where there's no street lights, no car lights, no buildings, anything, it's like incredibly different. Even if it's not a super clear night, if it's cloudy, it's still way, way clearer. So light pollution, I think, is probably one of the biggest ones.
Yeah, no, I think you're right. And I mean, even my house now, like I'm kind of in the boonies, but I still don't see what you would see in like a very rural area like St. Mary's. Like you see all the stars, and I never realized that. You also see lightning bugs, which are not stars, it turns out.
Fireflies.
There you go. Fireflies.
You call them lightning bugs or fireflies?
I think I call them both, but apparently lightning bugs because I just called them that. I wonder what the technical name is. Probably neither.
I think down south they're called fireflies, and up here in the north we call them, like, I don't know anybody calls them fireflies in Pennsylvania.
Stupid people.
All right,
Luke, what's next?
So I want to talk about, so I know we already did like telescopes in the past, but I feel like for folks that aren't going to go back and find that one, we need to do a little bit of history and a little bit of just tech on what a telescope is.
Okay.
So the first one is just the general invention of the telescope. So a couple things. So historians are not absolutely sure who invented the telescope.
What?
You would think. I think what it is because
it couldn't have been made that long ago. Well, come on.
Well, I'm not talking space telescope. I'm talking telescope, just the apparatus for magnifying things. Because you got to figure, there's people on one side of the pond and people on the other side of the pond.
There are ponds.
But in 1608, a Dutch maker named spectacle maker, those are eyeglasses, named Hans Lippershey. Henry announced a new lens-based seeing instrument that made distant objects appear much closer. So this is the first like really specific evidence of like someone specifically made something for magnification.
Gotcha.
So that was, again, 1608. There's generally two types of telescopes, whether it's a space telescope or whether it is a land-based telescope. So the first one is a refractor telescope. So a refractor telescope is a telescope that uses specialized designs of lens that focus light into a image. The larger the lens, and refractoring, the longer the optical tube needs to be. So these are telescopes that you would traditionally see that have really long tubes. So like those, the ones basically you think of like a kid would be using in their, like looking out their window. So these ones have some good qualities. So these ones are low image distortion. The images appear right side up because just the way the mirrors and different things work. They're very beginner friendly. And then the next one is a reflector telescope. So, and this is what most space telescopes are, because the reflector uses lenses that uses a mirror that then refocuses it to a focal point. So these ones have some really great qualities. They're really great telescopes. There's no chromatic aberration problems using mirrors. They capture tons of light, which we talked about is super important, like the distant light, not the light noise or the that we were talking about. So that's why most space telescopes are reflectors, and they're probably the best for observing like deep space objects, galaxies, nebulas, all that sort of stuff. And but the big problem is they need to be big. So the bigger they are, the better they are. So just something to think about. So I just want to do a little bit on the tech with those.
Did you also know that the bigger they are, the harder they fall?
I know you're not a dad, but that is such a dad joke.
It's true. Awesome. So I basically just have a giant list of all the different space telescopes that are out there or that were out there. So before we get into those, I think it's time for us to take a break for a word from our sponsor.
It has to be NASA.
It is not NASA, but that's okay. It's not the Russian space program either. Or what's the European like alliance of space
Isn't
programs
Space
called.
Force ours? Isn't Space Force ours?
Space Force could be ours. I don't know. But we do have 2 shout outs,
Who do we got?
regardless of this. Kaz O, K-A-Z, Kaz. My name is Kaz, and I graduated from Cal Poly Pomona with a bachelor's degree in mechanical engineering, not civil. Haha. I love it. I really love your podcast, and I'm a huge fan. Your guys' episode on finite element analysis. Oh, this is a good one. I love this shout out. Your guys' episode on finite element analysis, or FEA, actually helped me land a job at Boeing. The episode helped me understand what sorts of challenges you experience while doing FEA. I now support doing structural analysis work on the Apache AH-64 attack helicopters. Please do an episode on it in the near future.
How cool is that?
Isn't that awesome? We're basically smarter than Boeing.
Hold on. I feel like he owes us a portion of his salary if we are directly responsible for his employment.
Kaz,
it's like a finder's fee, right?
I mean, I don't know if Kaz is male or female, so I don't know if they owe us money or not, but I think they do. Just saying. Well, I like the Apache idea.
Yeah, that's a good
that would be a great one. But how cool is that? Our massive knowledge of FEA helped this cat land a job. Fantastic.
My goodness.
Yeah. Second shout out, Anthony C. Antony.
Oh, I thought you were being funny, like saying Anthony, like funnily, but no, it's Anthony.
I think so.
Okay.
That's it. But then again, you know how I say words. I just started listening to you all and can't seem to stop. I like that.
Of
I
course.
can understand
It
this
happens.
voice. This is by far my favorite podcast. I'm returning to school for mechanical engineering starting this summer, and this podcast is making me itch for it to start. Ugh, no. Even though it is more of a civil question, I would love an episode on the science, history, and implication of some of the major canals, such as the Suez, Panama, etc. of the world. I said, well, Anthony, go check out our episode on the Panama Canal, which we already did, but we have not done the Suez Canal, which I think would be fantastic. And then I'd also like to do one, Luke, about how we connect all those Great Lakes together and then make it to the ocean. I think that would be cool as well.
That would be a very good one.
Is there like a Lake Erie Canal?
There probably is.
Probably. It's probably filled with 3-eyed fish and stuff, but yeah. All right. Well, thank you for the shout out, everyone. Thank me for the shout out. Thank you for writing in. If any of you would like to write in to get a shout out, if you just want some friendly advice from me, if you want me to ignore your email, which a lot of people have been ignored recently, why don't you go ahead and email us at unprofessionalengineering@gmail.com.
And don't forget to subscribe, like, we love the reviews, share the podcast, and as always, you can tell your smart devices to play the Unprofessional Engineering Podcast.
Love it. Before I start talking about some of the space telescopes out there, would you like to talk about anything else first?
I don't think so. So I got a lot of stuff. So I'm hoping you hold on the James Webb until the end, because I think that's the most. It's clearly named after. It's named after you, James.
It is, yes, and my partner Webb.
Your partner Webb.
Very small participant. Yes.
Yeah. So. So I just have a lot on that one. So if we could hold that one till the end, that would be.
I'm gonna hold it. Okay, number 1. The Chandra X-ray Observatory. It's an X-ray space telescope. It studies X-rays, so it's not actually X-raying stuff, which is what I thought. It studies X-rays from very hot areas in the universe. These areas contain objects like supernovas, galaxy clusters, black holes, stuff like that. And this sucker was launched up there in 1999. 1 year before I graduated high school, and you turned about, 40?
Something like that.
Good. Yes. The satellite is over 100,000 kilometers above Earth, and it makes one orbit. It makes one orbit of the Earth every 64 hours. So it's moving around out there pretty quickly, I think. X-ray observatories like Chandra must operate from space because, again, the Earth's atmosphere nicely blocks X-rays from reaching the ground. So thank you, atmosphere, for that. Chandra has 4 curved mirrors, all kind of nestled together. And this is how I guess you kind of explained how that works. The discoveries that it's had would include observing matter around the black hole at the center of the Milky Way. which is pretty cool, showing how elements are thrown into space by supernovas. It found a bunch of new black holes and studying what happens to dark matter when galaxies collide. Like, this stuff is so out there. Like, it's so out in space, Luke, that I can't even wrap my head around it.
So here's the thing.
Galaxies collide?
When I hear stuff like this, I can understand. Go check out our Flat Earther episode. Did we do an episode on Flat Earthers?
We did, okay. Yes.
I thought we did, because I'm pretty sure we got some hate mail from that one.
Probably did.
I can almost understand why someone could say I'm a flat earther, because when you hear like the idea of galaxies like colliding and exploding in black holes, it seems like a science fiction movie, and the idea of the earth being flat is almost, it's not, because I'm not a flat earther, but it's almost more believable than colliding galaxies and black holes.
Yeah, I know. It just makes no sense to me, but it's fantastic. The next one that I have is the Fermi Gamma Ray Space Telescope. It observes the highest energy wavelengths of light in the universe, gamma rays, which we probably could have guessed from the name. The Earth's atmosphere also blocks these suckers, so it has to be shot into space or thrown by the big unit. The goals of Fermi were to learn about high energy objects and events, objects like, I love space words, like quasars and active galactic nuclei powered by black holes. Events like deaths of massive stars, which result in pulsars and neutron stars and supernova, things like that.
Isn't that when don't they make hammers and stuff like that in dying stars?
They do. Well, certain people do. Tyrion.
Yeah.
Lannister does.
Tyrion. I love our movie references. We are so on the same page.
We really are. This has been good. This is good. So this sucker launched on the 11th of June, 2008. It contains two scientific tools, a LAT, the Large Area Telescope, and the Gamma Ray Burst Monitor, the GBM. So just a couple of definitions, because they might help in other areas. A pulsar is a dense rotating object which gives off a beam of radiation for each of its magnetic poles. They come from neutron stars, the leftovers, which are the leftovers of supernovas. These recently exploded massive stars spin super fast and have really strong magnetic fields. So we're studying those. They sound dangerous. Stay far away. Pulsars, is that what I just did? That was what I just did.
Yes.
Quasars is an energetic object in space. It looks like a star. They're actually galaxies very far, far away, with very bright cores in the middle. They're probably the brightest objects in the whole universe. Fun fact about that, many times brighter than normal galaxies. A quasar can be as bright as 1,000 Milky Way galaxies.
You're kind of like a quasar.
I shine bright.
You shine like a diamond. Like a diamond.
Yes. And then supernova. It's a huge explosion in space. I didn't know that. They take place during the final stages of some stars' lives. When they erupt, one supernova can briefly shine brighter than a whole galaxy.
Wow.
Good job, supernova. Fermi's biggest findings, a pulsar which only emanated gamma ray light, high energy light ever seen from the sun, supernova remnants, active galactic nuclei only produced by a small amount of gamma rays. So they didn't find anything really interesting. And then I'm going to do one more before I let you take over with the Webb. How about that?
Sounds good.
Gaia, Gaia. First off, there's a board game called Gaia Project that you should all check out if you're really nerdy. Really good game. Gaia is this is the one, the European Space Agency. That's a terrible name. Why didn't I know that? The ESA mission. The goal of Gaia was to make a 3D map of the Milky Way. How cool is that? This map will help scientists learn how our galaxy formed and how it's changed over time. And Gaia was launched in 2013. It's expected to keep working until it runs out of power in 2025. Now, there's been a number of these telescopes that are going to run out of power by a certain year, and then they keep going, and we get a few bonus years out of them, which is
kind of cool.
Yeah. So fun fact, Gaia's map includes over 1 billion with a B stars. This makes it the largest catalog of its kind ever made. but it actually only is about 1% of the stars in the Milky Way. So it has over 1 billion, and that's still only 1% of the stars in the Milky Way. Gaia has been able to make many discoveries so far. It's found over 100 exoplanets, as well as high energy quasars, low temperature brown dwarfs. In 2014, it actually found the first supernova in the galaxy beyond the Milky Way. And then a little closer to home, it's also found more than 13,000 asteroids in our own solar system that we can now dodge or send missiles up to blow up when they're trying to smack Earth.
You just need Ben Affleck and Bruce Willis.
Or J-Lo. Oh no, that's a different thing.
No. You
Armageddon.
Armageddon. You got to
send. Gotcha. I didn't know Ben Affleck was in Armageddon.
Yeah, he was.
Liv Tyler was.
Yeah, they were boyfriend girlfriend or something.
Oh, were they?
All right, way too many movie references.
Okay, she was in Lord of the Rings. Anyways, with that, before we go on with the Webby Webs and my telescope, let's take a break for this week's Luke's rant. Okay,
so this rant is completely unrelated because we did this research like literally like weeks
maybe
ago.
A month
and
ago.
Just getting back to it now, but so I did this thing. It's called OMAZE. I'm sure you've seen it on your Facebook. It's a charity foundation organization that like partners with celebrities, like Mike Rowe is the celebrity for and what they do is you contribute like, $100, $20, and then you can win like this really cool camping van. So that's the one that I entered in.
Did you win?
No. I'm hoping I win.
Oh.
So don't anybody register for the van. It closes today.
Okay.
So I have better chances. But so first of all, check out OMAZE. They do all kinds of really cool things. They have great charities that they support. I love Mike Rowe. He's the dirty jobs guy.
I know Mike Rowe. He's
a great guy.
He does something about the universe as well. How the universe got started.
I think he may have. But so here's the thing. They are genius marketers. So I registered So I registered for this one donation thing, and it's a random drawing. It's all tax deductible. Yeah. I get so many Twitter, Facebook, my Alexa device downstairs, my Facebook, my Twitter feed is polluted with. So it's
that's my job, right?
I know it is. So I guess it is a little bit of a rant. So it's creepy how I went to a website on my phone on Facebook and donated money to now Twitter has it and my Alexa has it, and I'm getting emails to an email that I didn't give them. I mean, it's kind of shady, the things that you do, James.
I agree. I do a lot of shady things. I actually don't mind so much that they target me with ads for things that I'm interested in.
Yes.
I like that better than the random ads. But what I don't like is that somehow I think IP addresses are connected as well in all of this hoopla. Mm-hmm. And so then I start seeing stuff that my wife either purchased or has been browsing, or she sees the stuff that I've been searching up, and then she's like, oh, are we getting new edging around the lawn? And I'm like, yeah, we are. So that part I don't like.
I guess it's a rant. It's also kind of check out OMAZE. They have lots of good things that they do, lots of organizations and charities that they support. So check it out, but don't register for the RV. That's mine. I'm hoping I win.
Good luck, Luke. I thought you were going to say that we should be on there as a celebrity to
do
whatever it is that the celebrity does as part of this. We'll think about it. All right, moving on, Luke. Let's talk about my telescope.
Okay, so we got to talk about the James Herzing Webb Telescope. So I was always worried about you and I using our full names, but I just realized in the videos we produce, our names show up.
Do they really? They do.
I put them on YouTube. I was like, someone's gonna...
Too funny.
Oh, that's too funny. But I'm gonna. Everybody knows your name now.
There we go. I'm famous.
So the James Webb Telescope. So this is the most recent. This is like the big dog. This is
the big dog.
This is James Webb Telescope. It's a space telescope designed primarily to conduct infrared astronomy.
Oh, it's so infra.
It's the most powerful telescope launched into space ever, like literally ever. It is 100 more times powerful, clarity, whatever you want to do, than the Hubble telescope. Which the Hubble was the big dog.
Hubble.
Yeah, exactly. Pow, pow, right in your face, Hubble.
Yeah. Hubble.
So cool thing is it launched just not that long ago, less than a year.
So recently.
Yeah, December 25th, 2021. It cost, so now this was back in 2016, so I don't know if this cost is accurate. My guess is the budget overruns. It cost 10 billion with a B dollars to build. So
holy moly.
So let's talk about the deets.
That's a sad fact.
So it's very, very expensive. So again, 100 more times more sensitive than the Hubble telescope. So what happened on December 25th was
my kittens were 1 day old at that time.
Oh, how nice is that?
So there's that. Go ahead.
So the telescope is tightly folded into the payload bay.
This is so cool. Yeah, go ahead.
You've seen this? So tightly folded into the payload bay of an Airy 5 rocket. The launch vehicle was part of the European Space Agency contribution to the mission. A lot of times what they do is they'll share work, and NASA is kind of like the coordinator, so that they'll share information with NASA and the European Space Agency. So it's basically shoved into the cone. It was like an origami thing. They made this thing like super teeny tiny, small. They shoot this thing into space, right? Pew! That's our space shooting noise that we.
That was a tough word to come up with.
It was. But here's the thing. So you think, okay, it goes into space, it opens up, and it's done. No. Definitely not. So after the release from the bay, it takes a really long time for this thing to actually deploy. So once it deploys, the first thing that happens is the solar arrays start to deploy. So these are essentially super fine, very thin, very delicate solar panels, and it takes 31 minutes to deploy a solar panel. So once the solar panel, and literally that happens, again, 31 minutes, then this takes, on day 3, 2 specialized panels holding the Webb's sun shield deploy, because there's two. I
prefer it to be called the James, but go ahead.
Sorry. So crazy, the temperature from the sun side to the dark side, and I don't mean dark side like Star Wars. So
dark side of the moon?
The cold side with the sun, so they got to protect all the instruments, is 185 degrees Fahrenheit. The cold side, where all the instruments are, is negative 388 degrees Fahrenheit. Like, how is that? Like, whoever designed that sunshade needs to come insulate my house.
Did you see the sunshade is the size of a tennis court, which is bananas.
Enormous.
Yeah. And that the detectors have to be something like minus 266 or something like that degrees C to work. Like, they have to be that cold. Like, how do you even design stuff like this? So cool.
So on day 4, the tower holding the instrument package. So all this stuff was, again, origami. So imagine the sun, the solar panels go out, the sun protector comes out. The tower assembly then gets lifted to the operational location. So this thing comes out. Then the momentum flap is deployed. So as the sun's solar pressure pushes against the large sun shield, this flap helps stabilize the telescope. So the telescope itself isn't even, like, the actual mirror isn't even out yet. So this is day 5. So then the sunshine membrane covers and releases. So now the membrane and all the tensioning members to pull that sunshade. So imagine like a diamond shape, like you said.
I'm imagining it.
Size of a tennis court. So secondary mirrors start to deploy, and then this is where it gets super cool. So imagine hexagonal mirrors that are so finely machined, like size-wise, just start to like fold in place and end up creating like a dome. So if you imagine like half a tennis ball or half of a ball that was like the concave side, start to deploy and start to lock in place. Once all of this happens, the Webb will be able to observe over 13 billion light years away from Earth. Like, again, it's easier for me to believe that the Earth is flat than we can see things 13 billion light years away. So crazy. So a couple things. So it has a primary mirror size that is 6.6 meters. I'm assuming that's like 50 feet. I'm not sure.
It's around there, yeah.
Yeah, somewhere in that neighborhood. So that's the primary mirror. In comparison, the Hubble telescope is only 2.4 meters. So yeah.
Why even have that, Hubble?
Yeah. Yeah,
Hope
they
it
should
crashes.
They should just crash the Hubble into a planet or something
Hope
like
it crashes into Uranus.
That's a good. I think that would be interesting. So, so again, this is so light hits the primary mirror. It reflects back to the secondary mirror to the focal point, and then hits the instrument where it captures those images. And then all of that information is processed with all the crazy electronic stuff going on, and then beep bop boop, it gets beamed down to Earth.
Yeah, craziness.
I was under the impression there was like a Cat 5 cable.
Yeah, it's just connected down there.
It'd be so much faster, right?
Weren't we supposed to do an episode on the space elevator? Oh, that would be interesting.
Made with carbon fiber tubes. Exactly, I think we were.
This big old telescope is floating around in orbit of the Lagrange point 2, L2, 907,530 miles from Earth. I didn't cover this, at least in my notes, but go check out the different places that the satellites are kind of located in orbit. You kind of have to do a little bit of math to figure out the gravitational pull, as well as how fast these satellites are spinning to keep them in orbit. But this one's up there pretty far. Anything else you wanted to cover on the James Webb Telescope?
I don't think I have anything else specifically. I'm just looking through my notes here.
You look through. I'm going to talk about a couple others real quick. Like there's the Hubble, which we mentioned, which is basically a garbage telescope at this point.
Yeah.
27,000 kilometers per hour up in orbit. It orbits the Earth every 95 minutes. That's crazy. It was launched off of Discovery in 1990. Astronauts have visited a bunch of times. The light from Earth's moon takes about 1.3 seconds to reach us. So we know that when we look up at the moon and sky, it's actually 1.3 seconds ago. So we say this because when we're using these telescopes, we're actually looking back in time. We're learning about how the universe was formed, how the galaxies were all formed. Really interesting stuff. There's also the Kepler mission. So Kepler was a NASA mission to find exoplanets similar in size to the Earth. So it was all about looking for exoplanets near the habitable zone. Habitable zone.
The Goldilocks
places
zone.
We can live. It didn't find any planets that we know we can live on yet, but it found 2,600 exoplanets, including a Jupiter-sized planet very close to their stars, large Earth-like planets, and some others in the Goldilocks zone. There's the LISA Pathfinder and the LISA. So basically they sent out a little LISA Pathfinder, which was like a proof of concept mission in 2016. And then they shot up LISA with 3 separate spacecrafts, which traveled together around the sun. And lasers bounce light between the 3 spacecrafts. Beep, boop, beep, boop, boop. If the gravitational waves pass by, they will stretch and squash in space between the 3 spacecrafts, and this will change the distance the lasers travel, which again sounds totally made up. I don't know if I even believe that this is happening out there, but Lisa is going to be able to measure these tiny changes to then try and understand what's going on out in the universe. So that's kind of cool. And then the last one that I had to talk about was the Spitzer Toyota Space Telescope. It was brought to you by Dr. Lyman Spitzer, who also sells us vehicles here in Pittsburgh. NASA Infrared Telescope. It lasted from 2003 to 2020, so it just ended a little bit ago. And that's about all I had to say about that. Anything else for you, Luke?
No, I think that's it. I think the one I'm most excited about. So if you get a chance, there is a website. Basically, if you just Google James Webb Telescope, and there's a Reuters graphics .com. Reuters, Reuters. Okay. So that's where I got a lot of my information from. It has this amazing, like, as you scroll the page, it actually shows you all the processes that I just talked about.
Oh, okay.
About how
that's very cool.
It like unloads itself, and then it gives tons and tons of information. And there's a picture about halfway down that, like, I'm sure it's an artist's rendering of it. I mean, it has to be
Probably.
like it is incredibly gorgeous picture of what the the universe looks like. So check it out. It's graphics.reuters.com, and then check out space exploration.
Very good. Also, while you're Googling that stuff, why don't you check out the future space telescopes that are going to launch? There's 5 of them, major ones that are planned still. I'm sure more will be showing up as well, but really interesting stuff that they're going to be looking at. You can also send us an email while you're Googling stuff. So hopefully you all learned everything you would want to know about space telescopes. My personal favorite, the James Webb Telescope.
The James
And then
Webb.
the others that we mentioned that are less interesting. If any of you want to say hello, if you want to talk about space telescopes we missed, anything like that, email us at unprofessionalengineering@gmail.com. And until next time,
See ya.